Okay, so we're going to look at proportional and non-proportional relationships in the notes today. And I want you to look at what this says. It says linear relationships can be proportional or non-proportional. A proportional relationship means there is a constant rate between the values of x and y. Complete the table below and we're going to look at the differences. Okay, so let's talk about proportional. So first of all, a proportional relationship written as an equation is going to be in the form y equals kx, where k is the slope or rate of change. We also call that the constant, and again, I'm writing with my finger right now, the constant. Going to see if I can write it with something different. The constant of, nope, that won't work. The constant of proportionality. Proportionality. And I ran into the other space. Constant of proportionality. That's what the K is. It's also the slope or rate of change, but it's also called the constant of proportionality. The equation is going to look like something like this. Y equals 3x. Notice there's nothing being added or subtracting on to the end. And so that means that your y-intercept, it doesn't mean that there isn't one. That's really important. It means that the y-intercept is 0. The y-intercept is 0. So very important that you don't tell me that it's proportional because there is no y-intercept, because there absolutely is. Okay, if we are looking at a table, we can look for that y-intercept being 0, but the ratio of y over x is constant. It's the same every time. And that's our constant of proportionality. So looky here. If we say y over x, that's 6 over 2. 6 over 2 is 3. All right. If I look here and I do my y over x, that would be 12 over 4. 12 over 4 is 3. And then the same result here. 18 over 6 is 3. 24 over 8 is 3. And so that ratio, y over x, is the same every time. And that's unique to a proportional relationship. And so our constant of proportionality would be 3. Now, how do you tell from a graph? Super easy. It is any graph that is linear. Linear means that it's a straight line. And it contains the y-intercept of 0. We know that point right there in the center is also called the origin. So if your graph is going through the origin and it's linear, then it is automatically proportional. Okay, let's look at non-proportional. So non-proportional is a little bit more of what we're used to. It can be written in the form y equals mx plus b, where m is the slope and b, the y-intercept, does not equal 0. It can be anything except 0. So an example, y equals 3x minus 4. Okay, this has a y-intercept of -4, and so that's what makes it non-proportional. When we're looking at a table, the key thing that you're going to notice is that the ratio of y over x is not constant. So for example, 8 over 2 y over x is equal to 4. But if we look at this example right here, 14 over 4 is 7 over 2. And that is not the same thing. That is not the same ratio. And so therefore it is not proportional. From a graph, the way we could tell several ways. Number one, any graph that is not linear. So if you had like a squiggly line, then it would not be proportional. Or it does not contain the y-intercept of 0, meaning it's not going through the origin, which you can see right here. This graph is crossing down in the negatives. And so therefore, just by knowing that, just by knowing what the y-intercept is, you can tell that it is non-proportional. So let's look at an example. This first example you have on your note page. The second example, I believe, is in your weekly packet. So read about Hillary. It says that Hillary pays $30 per month and no sign-up fees. So there's no extra fees. She's just paying the rate. And so this is what her equation would look like. Okay, so if Hillary went to the gym, now let's fill in the table. If Hillary went to the gym for 0 months, she would pay $0. If she went for 1 month, 1 times 30 is 30, so she would pay $30. If she went for 2 months, she would pay 60. 3 months, she would pay 90, and so on. Okay, so let's draw this on our graph. We have 0, 0. We have 130, and I'm doing the best I can to draw these accurately. 260, 390. Now, if at any point I'm going too fast, stop the video and pause it for a minute and copy down what you have. So, is this proportional? And I hope that you said yes. You noticed immediately that it was a yes, but let's talk about why. In our equation, we know this is proportional because the y-intercept is 0, right? There's no extra amount being added or subtracted, and so therefore it is proportional. On our table, except for 0 over 0, you will notice, so number 1, we saw that the y-intercept is 0, so that's the first thing. But then you should have noticed that the ratio of y over x is the same for every pair of points in that table. 30 divided by 1 is the same as 60 over 2 is the same as 90 over 3. And then in the graph, it is proportional because it is linear and because it is going through the origin. Okay, so 2 reasons that we can state that it is proportional. Okay, so if you will pause the video, get your packet to look at the second problem. Reading about Javier, it says Javier is ordering sunglasses. He is ordering from a website that will charge $2.50 per pair. We know that that is our rate, so 2.5x, and of that flat fee of $5 for shipping. So start thinking, is this proportional? If he buys 0 pair of sunglasses, he's going to pay $5 no matter what. If I take 0, plug it in for X, he would pay $5. Remember, you can also type this equation into your calculator, into your y equals, pull up your table, and it will show you all of these values to help you out so you don't have to think of them yourself. If he orders 1 pair, he will pay $7.50. 2 pair, he will pay $10. 3 pair, he will pay $12.50. So let's graph that data. 0, 5. Whoops, I didn't quite graph that right. 1, 7.5, 2, 10, 3, 12.50. And so our graph looks something like that. And so what do you guys think? Is this proportional? I hope that you said no, and let's talk about why. Based on the equation, it is not proportional because the y-intercept is 5. Remember, to be proportional, the y-intercept has to be 0. In the table, we can still state that the y-intercept is 5 because we can see that. And you should also notice that the ratio y over x for each pair is not the same. Okay, and then for the graph, the graph is not going through the origin. Again, it comes back to that y-intercept, not going through the origin. Okay. I want you to pause a minute, and I want you to, I'm pretty sure I have these in your packet. So I'm going to put the answer. So I'm actually not going to pause. I'm going to end the video, and you're going to complete the rest of these problems from your packet using your notes. Make sure that you have glued your notes into your notebook.